My name's Chris. I'm with Tesuto. I'm one of the co-founders and the CTO. And I'm here today to talk to you guys about what we've been working on for about the last 2.5 years. We started in 2017, and we named the company Tesuto. It means test in Japanese. One of my partners is a Japanese American, and we liked the name. So what we were focused on is solving problems that we were experiencing. Our background is we came out of Edgecast, Verizon, Google. We were working on large-scale networks. Myself personally, I was in the core engineering department of Edgecast as a principal engineer. I was focused on global server load balancing, DDoS mitigation, all those kind of fun things. And what we found is deploying changes into those large networks, as you guys know, can be a real problem. You don't have representative labs. You don't have the means to propagate a change across some number of devices to see what will happen in production. It's just not feasible in the lab. And so what we started noodling around in early 2017 is how can we build a complete replica of a network? And at the time, I'd come out of Verizon, who had acquired Edgecast, and we were running about a 30 terabit per second global delivery network. And so I think we had a couple thousand routers at that point, and it was a matter of, is there a way for us to feasibly bring something like this into a virtual environment, to expand a lab beyond a couple physical devices, or even a large lab with, say, 20 or 50 routers in it? How can we expand that to really mirror what's happening in production networks? So what we did is we started writing code, a lot of code, for about 2 years. And we came up with a horizontally scalable system. So today, we support a large number of router manufacturers, and I'm going to go into those in more depth. But whether you're bringing up 1 router or 1,000 routers, your mean time to boot is the same across all those devices. And based on our background, we really wanted to focus on a software development lifecycle for networking. Obviously, there's a lot of talk and a lot of projects, companies, and effort around network automation, evolving the network, treating the network as software, any other catchphrases. But what we were focused on was in the network automation spectrum, from copying, pasting configs on a console to full software, deploying changes without human intervention, what are the tools that are needed along that path? So what we did is make the system as programmable as possible. So that's RESTful APIs, open source modules for Python, for Ansible, and then a full UI, so collaboration through team members and things like that is feasible. Again, my personal background, I've been in originally network engineering a long time ago, and then software development for about the last 15 years. My partners are Jay Sakata and Hossein Lotfi. Jay Sakata was one of the founders of Edgecast, took that successfully through the Verizon acquisition. While we were at Edgecast, we met up with a very talented performance engineer named Hossein Lotfi. He soon left to go work on the SDN team at Google. But acquisitions being what they are, after some time, we all came together and said, what can we work on? What's new and what's interesting? What pains do you have? And Hossein really brought this problem to us and said, how do we do this? We've talked about it at Google. We talked about it when we were at Edgecast, but we really still don't know how to do it. Do we completely build a system? Do we stand it up? Are we using tools like GNS3 or the various other emulation tools out there? Do we build something in VirtualBox or VMware ourselves, et cetera, et cetera? And what we found was there wasn't really tooling out there that met the need. And our first thought was, is it even possible? Let's take this idea and see if we can do something interesting here. Is it technically feasible? And after about 3 or 4 months of work, we were pretty sure it was technically feasible. We hadn't done it yet, but we felt like we were on the right path. And that was enough to kind of give us that bite at the apple. And we were all, at that point, started working on Tesuto full time. So as I mentioned before, there's this evolution happening. I mean, it's not that evolution is new. It's been happening ever since networks first started. But there are companies out there today, I've talked to them in the last year and a half, that literally deploy changes through copying and pasting configs onto a command line. And these aren't small companies. These are very, very large companies. And there are people already over here, intent-driven, self-provisioning, you know, the bliss of automated networking. There are companies that are very close to that or there. The vast majority of companies or networks out there are somewhere along the spectrum. And one of our key goals was to make Tesuto applicable to the journey. In all honesty, when we originally came up with the idea and started working on it, my immediate thought was, I want continuous integration for networks just like I have for my software tools. I want to make router changes, commit them somewhere, and have a test bed run against them, validate those changes, and then push them to production, just like the code I write. The reality we found is most networks are not ready for that. You guys probably know better than me. I think you're more hands-on with networks than I am at this point, but the vast majority of networks still have technical debt and architecture that doesn't lend them to automated changing on a continual basis quite yet. But there's a lot of efforts happening to get them there. And what we're trying to do is be a tool in that kit. So the state of automation, as I'm sure you all well know, is it's very complex to work on because of those lab requirements I mentioned. The constraints a physical lab brings from cost alone, power, physical space, all of those things. I know for myself, when I was at Verizon, we had a lab. There was always contention for the devices in the lab. They weren't configured the way I wanted them, or the topology wasn't there. We had people to work on them, so I could put in my request, wait my time, and I'd eventually get there. But it wasn't kind of on demand in my work cycle. And before I go too far into what I think is our solution and how to offset these physical lab challenges, I need to be clear that we don't replace a physical lab, right? You can never test an ASIC in emulated software. It just doesn't make sense. You're not going to check your packet per second rate on an MX line card or a QFX line card in software. So there's always going to be some physical requirements. But for a lot of the changes, the physical requirements are somewhat irrelevant. If you're pushing BGP changes and you want to see what the propagation to your peers is or what routes you're receiving, you can do that in an emulated environment just fine. And I'm going to talk about the software that's being emulated and the relevancy to production here in another minute. So honestly, I think we can reduce the physical lab requirement and also augment the functionality. So some of the things that we'll get into is we have the ability to expose data plane ports from emulated networks in the cloud. So you could tunnel a connection, whether it be MPLS, GRE, whatever tunneling protocol suits your fancy. You could create virtual tunnels into these emulated networks from your physical labs or your production back office to test your automation software and processes. So what we tried to do is, again, be the tool that fits a few of these issues. So I want to talk about the platform. I've talked around it a bit on purpose, but what we are is an emulation platform. Everything is a RESTful API driven, so even our own UI that we make available completely is driven by the public API libraries. We're cloud agnostic as we can be. A lot of our machines and customers are running in GCE. There's DigitalOcean. We have modules for clouds. We're essentially able to provision instances across various cloud providers at will. So a lot of what Tesuto is a very large orchestration engine. and it can handle everything from, containerized virtual images like CEOS from Arista to full KVM-based, behemoths like MX from Juniper.
So a question for you on that.
Sure.
So that because I really kind of thought in looking at Tesuto that you guys were orchestrating this and spinning this up inside your own cloud, but you're orchestrating it across a number of different cloud environments. Does that also mean, if I have private cloud and I want to run my own instances, I can do a mix of that and
Absolutely.
DigitalOcean, for example, so that the framework that you guys have built can glue wherever the horsepower is being run, you can offload that wherever you want.
Right. Absolutely. Almost. So we are releasing what we're calling our private cloud support later this quarter or very early Q1. So it'll be OpenStack initially. So if you came to us and said, I have an OpenStack cluster, I would need to be able to run 100 routers. We'd be able to say, you're going to need this many cores, this much memory, et cetera. And there are some kind of technical tweaks you'd have to make to it because the punchline I haven't got to yet is when we map these routers together, they're full L2 connectivity. They have no idea that it's not a physical link, so you have full broadcast traffic, and we can take that, between two instances in a POP or across the internet. So in the case of the private cloud, there's a few things you'd have to do to make sure that the MTU and things like that are appropriate, but absolutely. So
are we actually running the vendor's actual software for that specific
100%
on each one of these instances? Okay.
100%. So if you boot up an iOS XR, you're running the Cisco iOS XR software that's running on the hardware. Essentially what they do is they take their image, it's a binary, typically a KVM, and so your private cloud needs to support, VTX, which OpenStack can. But in the case of the software, it's the identical software, it just has a wrapper around it that acts as a shim between the hardware. So what you'll find is you're not going to use us to test throughput. That just is silly, especially if it's in DigitalOcean or GCE, because all you're really doing is testing their throughput with this highly containerized, virtualized device in the middle of it. So again, we pass all the traffic. In this example, this was something we did with Juniper for their North Star or SDN type stuff. They did a public webinar, and this was the topology they used for it. But all these nodes can pass L2 frames. And in situations like this, we can, I've stressed that you're not going to test your throughput or PPS, but there is a fair amount of traffic you could pass. In this particular example, I think we're able to pass about 5 gigs per second through the emulated network. So it depends on, obviously, the cloud provider as well as the image. In the case of some of the images, I think, for example, Arista, a lot of their public images are actually throughput limited to 1 gig, which for testing and these environments is more than enough in almost all cases.
I mean, it would seem that this would be more like something that you would use for control plane
Absolutely.
testing, not necessarily throughput performance.
Yep, and I've got more information coming on that, absolutely.
Do you get early access to code?
We have very good relationships with the big three, I'll say, Cisco, Arista, and Juniper. We're talking to them on a regular basis. In the case of Juniper and Arista, we are getting pre-release code in some situations, I wouldn't say all, but based on mutual customers, we have an open pipeline and lines of communication into them. So, plus, especially Hossein, my partner, he's worked in that networking space for 15 years, I believe. So the number of people he knows just blows me away. I've been in the same industry for the same amount of time, but I sit in a dark room in front of a computer and try not to talk to people. So, so to talk about the platform a little more, The big challenge, when I started, I talked about we weren't sure if it was possible. The part we weren't sure about being possible was the layer 2 interconnectivity of the virtualized devices. It's kind of, there's kind of an inception of virtual machines here because we're in a cloud, so that, our machine is a virtual machine, and we're creating a virtual machine so that we can create a pristine environment for these router images, which are also embedded virtual machines. So you have these layers of virtual machines, and how you map the interfaces, the topologies, and ensure that you have, the maximum MTU possible on a layer 2 frame so that we're being as close to production as possible was the real challenge. And so we did come up with a system to build these overlay networks. We've had a patent issued on it. We're working on some other intellectual property in this space, but this is the kind of the core component that says, sure, we can do this in Google, we can do it in DigitalOcean, we can do it in your cloud. It's because we can build these overlay networks and ensure that the traffic we're putting through them is only what we want and how we want it. I guess you'll hear me say this a lot of RESTful APIs. This is really intended for networks and machines that have large requirements. We expect these to be integrated into kind of, automation tool chains, and are trying to be as flexible as possible to what those are, whether it's Ansible, Salt, Nornir. Our personal preferences, we're very Python heavy, so we already have a public Python library, so you can import our module and do things like, list emulations, create emulations, et cetera. And I'm going to talk a little bit about our roadmap and features, but we have a public Ansible module that's coming this quarter. So part of the demo is I'll give a preview of that.
You guys are supposed to be releasing a new Python module that reduced the amount of code that your users had to write for CI validation. Have you guys released that yet?
Yeah, the Python module is released. Absolutely. And I mentioned the orchestration engine. So somebody mentioned this really feels like it's for the control plane, and that's absolutely right. The management plane, control plane is where this solution is focused. There is limited data plane throughput. We can expose data ports to the internet. So it's not that there's no data plane, it's just the kinds of testing you typically do on data plane probably aren't applicable in this emulated world.
So that I have a question about the network operating systems, and if you're using features that are based on custom ASICs or something like that, because you're not focusing on the data plane, you can't really test those out or emulate those, or do you have a solution for that?
I wouldn't say we have a solution for it. And I think the answer depends. For example, in the case of Juniper's QFX, they have line cards. So Juniper actually has released a Dockerized version container for line cards. So you can stack line cards in there. So you can get the, let's say, full port topology and representation that you would expect that you'd see in production. But there's no value in trying to test some functionality of that line card. That is where the emulation stops, right? That it just doesn't work. And so at that point, they're just forwarding packets kind of on the Linux bus, I assume, and you're getting no actual representation of what's happening in a line card in production.
I actually got two questions. I'll make it quick.
Fire away.
So today, let's say I want to emulate Juniper inside VMware. It takes a tremendous amount of effort to get all that spun up. I'm assuming you guys make this pretty push button click and you're kind of off to the races, right?
That is the goal.
Okay.
And I'm going to show you it here in a minute so you can judge for yourself.
Number two, how difficult is it to add additional vendors? So I see you got like 8, 9 something vendors.
Yeah,
here.
I think we have a few more than what's on there.
Yep.
Adding vendors is relatively easy, provided they're already building virtual images. So, for example, Palo Alto's not on this list. We've had some requests about Palo Alto. We know they have KVM virtual images, so we know for us it's relatively simple, trivial, less than a sprint's worth of work to put that thing on our system. If they don't have KVM images, but they have some other more exotic solution that we're able to use, then we're more than willing to look at that. So I don't think it's dictated by us very much. It's dictated by what's available from the vendor.
Okay.
So.
Here's a question for you. So you guys support, I assume, like Azure, AWS?
We have a module for Azure. We haven't released it. So we're growing our cloud portfolio. So today in production, it's Google and DigitalOcean, and AWS will be next, and Azure very shortly after.
Okay, so when you do release that, I guess my question is those vendors have, a lot of, they're different, but they have a lot of things they do under the hood when you spin up machines, right? Mm-hmm. So if I went into Azure, for example, and said I need, would I have the ability to say, well, I want all these different routers here on a different availability, I want to put them in an availability set, and spread the load out across, or how, in other words, how much control, I guess,
do you have
is what I'm asking, do I have on the underlying infrastructure, or do I still need to take a tool like a Terraform or whatever and build my infrastructure first, then take your tool and apply as if I'm just building virtual machines on top of it?
So I don't think you would need another tool. Our software provisions everything from the instances to the interfaces in the cloud provider. So I don't have any expectation that you would need any other software to make that happen. The way it works today is that the virtual machines, you're basically using minutes from Tesuto. And regardless of what the back end is, whether it's GCE, DO, whatever it might be, we're offering uniform pricing on that. So there's definitely been questions about, well, I have my own cloud account. I want to run this on my account and not pay you for minutes. And to that, I would just say, we have business people that I'd love for you to talk to. And nothing's impossible, right? So
fair enough.
So just a quick clarification on things. You mentioned that in order to bring a vendor up, so like you're talking about Palo, they need to have an emulated version of their software.
Well, a virtual disk image, yeah.
So understand that part, but kind of going back to it, when we're looking at the vendors that you do have, would that really limit us to certain versions of the operating systems at that point, or certain platforms at that point, depending on what
yes
it was?
and no. Okay. So we have to bring, if there's a particular version you'd like, we need to bring it on board. So in the case of Cisco, though, that's trivial. That's a half an hour. I've got this version of iOS XR. You guys only have these 10 in your list. Okay, no problem. So that happens frequently. I think just in the last week, Hossein added maybe a dozen new versions of vendor software, and I think across the board. So we're basically trying to stay current, right? If we go back about 18 months or so, that's when we started bringing these images into our system, and so now we're just trying to stay current with their release cycles. So eventually they'll all be there, but we talk to customers who have special builds from a particular vendor that's specific to their environment, and we can bring those images into our system for them, lock it down to that organization to make sure nobody else is able to utilize it and things like that.
Now, are you finding that varies based on hardware platforms, such as Nexus 7K versus 9K versus 6800 versus whatever?
For the most part, right? Let's say, before I start talking about routers and vendors, I think it's pretty clear everyone here probably knows more about them than I do. So in the Cisco world, though, there's 3 lines of software, right? And there's umpteen lines of hardware. But really, it boils down to 3 tracks of software. It's the iOS, the XR, and what's the other one? The
XE.
Yeah, XE. So we have versions of each 3 of those. As far as the chassis or representing the chassis, that's more abstract and less relevant, because that's really just defining what physical hardware is out there, right? And in this case, there's no physical hardware. So you can choose which particular software line you need or want, And then if there's a version within that that you need that we don't have, it's a very simple task for us to bring it on. And eventually, hopefully, self-service. But today, you'd ping us, email, Slack, support, whatever it be, and odds are within an hour you're going to have it.
I have a quick question on the management
Yeah.
side. So you say because this doesn't have the hardware platform support, but do you still allow config validations for things like the actual
Absolutely.
hardware checks against it, so you can at least ensure that what you're putting against a specific line card?
100%. So you can essentially specify an interface range, and we have a shorthand that allows you to not have to type out, say, 300 gig E / slashes, but
Right. Well, what I mean by is you actually understand the context portion of what can be applied against that interface type. So because this interface type, there's
I
certain
see what
cases-
you're saying.
So like on the Nexus card, F cards have a certain set of capabilities versus M cards, right? So you want to know what you can apply command-wise against each one of those. Is that something
That's something I'll have to follow up with you on. I don't want to give you the wrong answer. My gut says that it might not be that intuitive, but I would need to talk to my partner Jay, who's really focused on that lower level emulation and how that would apply. But I'm happy to do that.
I don't know if this is actually something you'll be able to answer or have the answer to, but somebody asked on the internet if you're going to support multi-host /node for scalability with the private cloud release. So I'm assuming we're talking
I'm
like,
not sure what that particularly means, because if you need to spin up 5 routers and you've got your private cloud, does it matter if it's 1 instance in your private cloud or 5 instances? The CPU and memory requirements stay the same.
well, I think it goes back, I mean, it sounds like it's going back to my original question about Azure with, with availability sets, a similar idea if you wanted to have some, fault tolerance built into your lab network, essentially, beyond, okay, I've got 150 routers, I'm running all this BGP, I'm doing this, I'm doing that, and I want to be able to, simulate what happens if a data center goes down, and now I've got, 28 routers crashed because all this hardware,
Right.
went down. Do I have the ability to do that by, putting the stuff out across? How much control do I have on the underlying build, or are you just going to spam, I mean, bad word, but just spam, 100 routers out across whatever is available?
You have region control, but beyond that, not much today.
So then the same thing would go to the private cloud, so OpenStack or whatever. I mean, how much control do you think we're going to?
Well, if it's in the private cloud, you obviously have a lot more control inherently, and in that private cloud model, there is going to need to be, I guess, a little bit of professional services, for lack of a better term, but there's going to need to be some back and forth so that we're giving you exactly, what you're expecting in that scenario. And if part of that is you need the ability to control more of these lower layer functions, then, certainly they're being used by us, right? So
Right.
it's possible.
Okay.
It's definitely not something we've focused on thus far. It's the first time I've heard the request, but.
Quick question for you. I know you have a lot of questions on this slide, but
That's okay.
I noticed you have Mikrotik up there, and that was in it. I work a lot in the Mikrotik space.
Sure.
In fact, we're one of their largest consulting vendors globally, so I was curious to see, we don't often see companies like Mikrotik for routing in TFD presentations, so are you guys getting a lot of demand for their CHR?
We got some demand, I'll tell you that.
Yeah, apparently it made it on the slide.
Right, exactly. If we support it, there's a reason. We're a very small team today, so it's not like we're just out there bringing on images. Today we're obviously driving business. So I don't honestly remember the context for which it came about, but I can find out.
Cool, awesome.
He did it just for you.
That's what I heard.
Okay, so let's talk a little bit about what makes us different. And when I say what makes us different, the kind of assumed question I'm hearing is, why don't I just use GNS3? We hear it often. And I think for folks like yourselves and kind of the target of what we're looking for, it might be fairly obvious. I don't know how you would take 100 routers and emulate them in GNS3. I mean, yeah, I guess you could go into GCE and build yourself a machine with 300 cores and, I don't know, a couple however much RAM. And, I guess it could be feasible. I wouldn't want to do it, but, there are a number of things that we focused on and that I think really explains why GNS3 isn't going to work in all situations. If you need to spin up one router and you've got the ISO or the QCal file, then yeah, GNS3 maybe is simpler, right? But if you're a NetOps or a NetEng for a production network and you're doing these things on a continual basis, then it has shortcomings, right? So I'm going to start speeding up a little bit so I don't run out of time. Something we're going to talk about in the demo is the integrated validation engine. That's a big part of this. We work with Napalm. If you're familiar, it's an open source project that does network validation. There's an Ansible module. It's YAML driven. It's pretty good. There's also OpenConfig with Yang. So for our purposes and what we were trying to accomplish with Tesuto, we decided to adopt Napalm first. Doesn't stop anyone from using OpenConfig with our platform at all. It just means from within our platform, when you add a device and you link, say, two routers together and you want to throw a test that verifies their LLDP connectivity, there's a template that you can plug the host names you want to use in. And when you start that emulation, we'll automatically run that validation for you. I'm going to skip programmable APIs. Config management. So you can store configurations for your virtual devices in our platform. We call them emulations. Basically, an emulation is a virtual network with however many devices it may have. You have the ability to export those and import them. So if you're working with a partner or a vendor and you're saying, here's the problem we're having, and you're both using Tesuto, one day, years from now, you just pass them that export file, they import it, and they have the exact same emulation you have. You can also clone it, fork it locally in your account, and have variations off of it. So a common theme we see is you create the pristine network image, the one that has all the right links, all the right config versions, and the config's uploaded, and then you want to start trying things, so you clone that one, and then you break the one you cloned. We talked about the public data ports. A big reason why I think GNS3 breaks down is not their fault. It's that a Juniper MX router takes 25 minutes to cold boot, and there's no way around that. And if you're on a laptop with however many cores, you're only extending that time, not bringing it down. So we've spent a lot of time and effort, on what we call rapid initialization. Folks like yourselves might call it suspend resume. So we have the ability to freeze a virtual router at just before a particular state in its boot process where it's coming online, so that once you get through that cold boot process once, you can suspend it and resume it with a sub 5 minute mean time going forward. Okay. So I want to talk about some use cases. We've talked a lot in theory. I'd like to talk a little bit about where our platform's being used or has been used. I don't know if I've seen any of you folks at NANOG, but every year they do a hackathon. So for the last 3 years, they've started using Tesuto, and NANOG 77 is in 2 weeks in Austin. I'll be down there. This year's NANOG is on traffic exceptions. So they don't force people into a particular topic for the hackathon, but it's kind of a recommended pairing with the topology they create. So this is the topology they're using for the hackathon. And with varying levels of flow control, how can you handle exception traffic? So these hackathons usually have anywhere from a dozen to 20 plus teams. So again, they create that pristine emulation, they clone it for the number of hacking groups they have, and each group gets their entire own network to play with. as a sales engineering tool, we have a great relationship with Corero. They're a DDoS appliance. And so they have a virtual image, and they use it in our platform, and they standardize on us for their SEs to use as a sales tool so that when they go out and they need to do a demo, they have this relatively small emulation where they have their device, an MX router, and then they're simulating, attack traffic through their appliance. Training. So one of our longest relationships is with Jason Edelman, Network to Code, good people over there. And so all of their training classes for the last year or so, I think last year, don't quote me on it, have used Tesuto as the virtual lab. They were using Ravello before, Oracle sunsetted that product, but prior to that, long prior to that, we had a relationship with Network to Code. So their classroom setup is they have a virtual dev machine, Ubuntu machine that they put their tools on, their automation software, their coursework, and then they standardize that image through Ansible in our platform so that they can create the emulation once, clone it out for each student, for each class, and away they go. Okay, last one, and then we're going to some demo stuff, I think. So this is the one that's near and dear to my heart because this is the one that I really wanted to do when I was an engineer working on a production network, and that is pre-production testing. So in this particular example, there's a service provider out there who I can't name, but they are wanting to test BGP streams coming in from, I believe they have an open BMP server in their back office or somewhere. And they have an exposed data port on an emulation in our network. And they're feeding that data through a tunnel. They're very security conscious, so none of this is exposed to the internet except the tunnel. And as they make changes, they push those changes through a pipeline that involves feeding the data here, verifying the results, and then allowing it to continue through that cycle.